So awesome to be with you tonight. Ladies and gentlemen, thanks for joining me. Thanks for taking an opportunity to build your character and your intelligence, doing things the way I'm asking you to do them. If math has never been your favorite or your best, it does not matter. You can still do it. I know you can. I believe in you. Believe in yourself. Show that principle of intelligence called confidence, and believe in what I'm telling you. It will make a difference. So, ladies and gentlemen, tonight, lesson 2.5 from your Big Ideas book, page 72. And I know you've already read them. I know you've already taken a few notes on them, so you have an idea of what we're going to be talking about tonight, so that I can reinforce. Remember, taking your own notes is a part of self-teaching of principles of intelligence. And then I reinforce that teaching by talking about it with you and going over examples with you. It all works together. Trust the process, ladies and gentlemen. We're continuing with transformations. Now, ladies and gentlemen, we are not going to actually do a transformation tonight. We are going to do something that is very critical to what our next transformation will be later on in this unit. So we have to learn about similar figures. So we're going to apply what we learned and use the formal definition of similar figures to identify similar figures and find missing values. Our essential question: how can you use proportions to identify similar figures and find missing values? Ladies and gentlemen, remember proportions back from 7th grade. One ratio is equal to another. And how do we solve proportions? That's right. We use our cross products, and we know our cross products are equal. And if they are, we have a proportion. So the notes that you should have taken down look something similar to this. So all you have to do right now for me to reinforce what you wrote is to sit back, relax, listen, watch, learn. If there's something I write up here that you want to add to your notes, by all means, when I'm done, hit the pause button, get it written, and then move forward. Don't try to write it while you're trying to listen and learn it. Always pause the video. All right? So, ladies and gentlemen, similar figures. Want to talk about it. Similar figures. The information that they give us here is really good, but I want to connect it all together because these similar figures are important. And there's 3 things to learn about similar figures, just like there was 3 things when we learned about congruent figures. 1, it has what? That's right, same shape. You got to have the same shape to be similar. That only makes sense, right? Same shape to be congruent, same shape to be similar, kind of like each other. All right, and the second thing we want to talk about is corresponding angles. Corresponding angles have to be congruent. Corresponding angles are congruent. We see they're the same exact measure. So the second bullet that they gave us right here says corresponding angles are congruent. And then they listed the corresponding angles and showed you the congruent statement with that of the picture for triangle ABC and DEF. Okay? Now lastly, we want to talk about corresponding SPONDI. Corresponding sides. Corresponding sides are what? That's right, proportional. Corresponding sides are proportional. And what did they say in the first bullet? Corresponding side lengths are proportional. And they wrote down the proportions right here for the side lengths. Voila, bam. Okay, so if I wrote something that might help you, if this helps you, then write this down because it's quicker and easier to remember than all that stuff that they put there. Now I'm going to ask you to pause and then write if you need to. Otherwise, one more thing I need to talk about on this page, and I'm going to erase everything I've written. So here we go. We're going to talk about the similarity statement that we use in mathematics. And so when they're saying triangle ABC is similar, it's just one wavy line without the equal sign to DEF. However, corresponding parts are still in the same relative order. Oops, I connected it to the wrong one. They're in the same order with each figure. So important with that similarity statement. All right, so let's do some of the math. Identifying similar figures, using what we just learned and using the formal definition of similar figures to identify. 1, same shape, we're going to assume these are the same shape. They look pretty much the same to me. Two corresponding angles congruent. Well, corresponding angles might be congruent. Here's one thing you should know. If the side lengths are in fact proportional, then the corresponding angles are definitely congruent. We can prove that in class. Corresponding angles are always congruent, especially if the side lengths are proportional. You can have congruent angles without the side lengths being proportional. There's no doubt about it, but it doesn't work the other way. So we're going to use our proportionality to find out if these two figures are similar. So I'm going to do it two ways. One, I'm going to use the larger shape, and I'm going to write my first proportion, my first ratio of the proportion using the larger figure first. So I'm going to take this vertical side to the horizontal side, and I'm going to go 20 is to 15. So I'm writing a ratio of the larger figure. And now I need to write that in regards to the corresponding parts in the same order. So if I go vertical first, I have to have 4 on top of the smaller one and 3 on the bottom of the smaller one. Now I can come over here and I can say, hey, 20 times 3, that's 60. Nice. And 4 times 15, that is also 60. So yes, these are similar. Yes. Yes, yes, yes. Because those cross products were equal. The proportion worked. So these two figures are proportional. That means they are similar. The second way I'm going to do it. And of course I am going to write a proportion. But this time I am not going to go with one figure to the other figure. I am going to change it up. I'm going to change it up by saying corresponding sides, just like they did in the notes. So corresponding sides, from the larger to the smaller, the two vertical sides, 20 is to 4. I'm going to change it up a little bit. I'm going to use the diagonal side. For the larger one is 25. For the smaller one, it's 5. So 25 to 5. Now I always go the same direction. So that, notice the larger's on top of both, the smaller one's on bottom of both. Hey, I could have gone the other way. I could have gone 4 to 20 and 5 to 25. I can go smaller to larger if I want. Now I come in here, I go 20 times 5, that's 100, and 25 times 4, that is 100. So yes, we have similar figures. So either way you like to write your proportion. Remember, I could write 8 of them. Since these do form a proportion, I could write 8 different separate proportions. Well, actually more than that because we're talking 3 sides. I could write 12 on this one. 12 proportional statements that work on this figure. Let's do one more before we're done for the first video, telling whether these two figures are similar and explaining our reasoning. And again, we're going to say that they're the same shape. Again, we can see that the corresponding angles are in fact congruent by the way they mark them. But now we're going to check the side lengths. We're going to check the side lengths. So we want to find out. And I'm just going to do it one way this time. And I'm going to say this 12 to the 8. The longer side of the larger one to the longer side of the smaller one. So 12 to 8. Is that proportional to the smaller side of the larger one, 9 to the smaller side, the vertical side of the larger one, 9 to the vertical side of the smaller one, 5. Are these proportional? And then I'm going to grab my cross products. 12 times 5 is 60. 9 times 8 is 72. These are not proportional, so not similar. Make sense? Nice. Ladies and gentlemen, you have your first quick write. Go ahead and copy these figures. Go ahead and label the side lengths on them. And then using the part of the definition of proportionality, tell me, are these figures similar or not? And then take a quick break before you come back and join us for the second